Ladies and gentlemen, the day has finally arrived. It is our introduction to mechanisms today. We're going to start with basic exercise. We're going to put mechanism arrows down. We don't know what those are yet. Some of us might. Need a pen that I can write with. I like my arrows in red. You do not have to use red. Here's an arrow. I will say a lot of words. The arrows are the most important part. But I'm going to tell you every time where this arrow starts and where it ends. And look, listen to the words I use. This arrow starts at a pair of pi electrons and ends at an H atom. You agree? I didn't lose anybody, I hope. Do you want me to say it again, just in case? The arrow started at a pair of pi electrons. It ended at an H atom. It made this bond if you're making this product, this bond right here. That's a new H there, isn't it? And it made this bond if you use the pi to make the bond to this carbon. So your new electrons are this bond and this bond. And this arrow starts at the sigma bond between the H and the Br, and it ends as a lone pair on Br. You want to see it? There. Now, I expect everybody to know everything about introduction to chemistry. There's no one in this room that believes this Br has one lone pair. It would have a formal charge of +5. That's a unicorn. How many lone pairs does a halogen need to have to be an anion? Every one of them. 4. It needs to have 8 electrons around it to satisfy the octet. It's in group 7 on the periodic table. It has one more electron here. Here are the electrons that were already there. So what about lone pairs and mechanisms? I only need to see them when you need them. So I really didn't have to put any lone pairs over there because I'm not using them for anything. Okay? But the red one is new. Okay? Same story over here. When you did it and made the H bond indicated to the left, you also made a Br minus. Okay? All right. So what's going on here? So where do arrows start? Okay, well, we started this pair on a pair of pi electrons. And I want to be as general as possible. There's your symbol for electron. Did this arrow also not start on a pair of electrons? I think my words cover both arrows, don't they? Where did it start? On a pair of electrons. In this case, pi. In this case, sigma. Okay. Where do they end? Well, this pair ended at an atom. At an atom. Or on an atom. If they end at an atom, you made a new sigma. If they end on an atom, what did you get? Here, they're ending on the atom. What did you get? Yeah, and it didn't have to be an anion. If it started as a plus, it would end at 0. It's not about the charge. It ended as a lone pair. Yeah. On an atom, lone pair. Later on, we're going to add one more to this list. I'm just going to leave it open for now. We haven't seen it yet, so it's coming. Yeah. And how are they graded? Well, let's see. I can answer that this way. I'll redo the arrows and tell you how you lose points. So here's the same alkene. Okay. If you want to lose a quarter point, you can start out here. You want to lose another quarter point, you can end it out there. You want to lose another quarter point, you do something like this. I don't know. I'm trying to show something that's just wrong. I don't know, something like that. Every one of those arrows is losing points. Minus 0.25 out here. Why? Started in outer space. You're not allowed to start in outer space. Minus 0.25 here. Ended in outer space. I know outer space is a weird expression, right? Just, it's nowhere, okay? Why is this arrow losing a quarter point? There's no electrons that it started on. Minus 0.25. So this is how you're losing points, everybody. How are they graded is in green, okay? Minus 0.25. Didn't start on electrons. Okay? So the top mechanism is just ignore it. It's garbage. The one on the molecule here is good. Okay, now this next one, yes, you may. That's not you, that's you. Yeah. Hope that didn't get on the video. I don't think it did. Ladies and gentlemen, if you don't do this, for example, if you just do this, I see it a lot. I'm just going to put C+ here. You're going to lose a quarter point. Minus 0.25 did not start at a pair of electrons. Okay. All right. I don't know where activity 1 is.
This one right here?
You might have found it. Yeah, that's it. All right. Keep that for now. Okay. So I need to see this. Did you see me draw this lone pair? I had to. Why? I'm going to use it to make a bond. And I have to start lone pairs on a pair of electrons. A formal charge is not a pair of electrons. Get that in your head. There will be probably 5 people in this room. Pretend on the next test that an anion is a pair of electrons. It is not. It's a formal charge. It's a mathematical calculation. It isn't a pair of electrons. So I start on a pair of electrons and I'm ending right at the carbon atom. I hope you agree. So where do electrons start on a pair of electrons? Where do arrows start? Sorry, arrows started on a pair of electrons, ended at an atom. That's one of your options. And it made this new bond, didn't it? If you need a lone pair, you must draw it. We got a question. There's your lone pair that you need. Yes. For mechanisms, you always have the products given. Yes, you don't have to invent products on mechanisms. That is another part of an exam where you do have to predict products, separate section. But on any mechanism question, the products you need will be there. So same story, start on a pair of electrons, end at an atom in this case, making this bond. I hope you agree. There you go. I don't have to add to my list of starts and ends there. Those weren't new, were they? Now the next one, don't forget what I taught you in chapter 4. Cross off the piece that doesn't do anything. What's that? Potassium is a spectator. I need, once you've crossed it off though, you have to do this. You better tell me you acknowledge that you crossed off a plus. You better put the minus down. You need at least one lone pair. You need one lone pair. Hydroxide has 3 lone pairs. I need 1. And this is a acid-base reaction, isn't it? Yeah. It ended at the H atom and it made a bond. I can't show that bond. I can, it's right here. It's red, it's very small. Right there. And what happened to this pair of electrons? What did it end as? Say it again. It ended on an atom. So it's a lone pair. And because you need the lone pair in the next step, you better put it there. There's 3 lone pairs on that O. I need 1. And the next step is, what do you call that when things are just going back and forth without atoms changing position? Resonance. There's a mechanism for resonance as well. Here it is. The arrow starts on a pair of electrons. You're already good with that, but it's ending in a new place. Watch. This is not on the list of where arrows can end yet. Where did they end? Between 2 atoms? Or between 2 atoms? And what kind of a bond did you make? Pi. 2 atoms. And when you do such a thing, you make pi bond. There. And that's it. Oh, there's one more arrow. Tell me the arrow I didn't do yet. If I stopped with this arrow, here's what you get. You want to lose a full point and a half? That arrow creates this situation. I have some experts in the room that can tell me the result on your exam when you draw anything like that, and every time you draw something like that, what is the result and what is the points ramification? What's your penalty? I'm going to write OV. It's total garbage because it's got 5 bonds to carbon, and you lose a point every time you have an octet violation on every exam. So just don't do that. I missed an arrow, that's all, right? What's the second arrow? Where does it start? On the pi bond. I like how you said that. And where does it end? I like it, on the oxygen atom. Perfect. Yep. So you don't have to worry about that OV now. So I made a 5th bond, but I compensated by breaking one of them, right? Then you break pi. Makes sense, it's weak. Weaker. Students like labeling once they figure it out. They do. Where do arrows start? I'll give you some letters. L, B, comma, nu. Where do arrows start? Look at part F and tell me what LB stands for. Lewis base. What's nu stand for? Nucleophile. They are always synonymous. I like remembering them as Lubnu, like I wrote them, because it sounds like a name. It sounds a little like an Arabic name. Arabic, Slavic. I had a friend named Luba in high school. It's right in there, you know? Lubnu. And where do they end? Well, they always end. I'm sorry about the order changing here, but I change order so I can remember the sounds. I'm a sound guy. My brain works in sounds. I'm a very big minority, a small minority, okay? Most people are pictures and words. Eli, it sounds like another name. That's why I put it that way. Doesn't it sound like a name? Like Eli, Ela? Okay. An electrophile. That makes sense. Why are these electrons pointing at me? Because I love them. I want them. Isn't that what electrophile means? Mechanism arrows are motion of valence electrons in reactions / resonance. And resonance is often part of the reactions anyway. Motion of valence of two. Let's be more specific. Of two valence electrons in reactions in resonance. So it makes sense they would point towards something that loves them, right? Electrophile loves them. That's where they end. And Lewis acid is an electrophile. Always. Lewis acid. Lewis. You hear the man's name. And I already don't like it. It's a man's name. It means nothing. If it was a woman's name, it would still mean nothing. I'm sorry, ladies. But it's a name. It doesn't help us learn stuff, and I hate it. It's got to end someday. It's not going to for a long time. It's been around for 300 years. Okay, 200. Okay. So when you hear Lewis, you replace it in your mind immediately with two words. Valence electron. That's all it's ever been about. When you learned Lewis structures, that's what it was about. Do you agree? Way back in 141. Valence electrons, okay? So we're talking about valence electrons. Lewis. So your definitions that have Lewis in them better start with electron. And you have two choices, electron donor or electron acceptor. Please remember it this way. Electron acceptor. Don't even say the word electron. Pretend the E's not there. Electron. You know, you're a hip street kid. Yeah, electron. What's electron? I'm electron acceptor. Electron acceptor. What are the letters? Forget the E wasn't there. Ladies and gentlemen, LA has the definition in it. The letters have the definition if you say electron wrong. Electron acceptor. Well, what's the electron donor then? It's not LA. Lewis base is the donor. Hey, what's the synonym for Lewis base? It's in a box on the screen, top left. Nucleophile. What's in a nucleus? That's, I like you said protons. Forget about the neutrons. They don't have any bearing on this argument. Yeah, it's all about charges with reactions, right? So you're a nucleophile. You love a nucleus. What charge do you love? Plus, because it's in the nucleus. Okay? Well, you're going to donate electrons towards that plus, right? Lewis base, electron donors, right? Nucleophile, Lewis base, they're synonymous. If you use one, you have to use the other, or else you're throwing away a half point. Oh. So we always have Lugnu and Ela. If we're using arrows, your Lugnu and Ela are in play. Bronsted is not always in play. And I should have given Bronsted a little more credit to his nationality. I think it's Dutch. I might be wrong. I'll be getting hate mail. Sorry. Okay. Bronsted. I don't even think I said it right. So that's all about protons, everybody. Bronsted's about protons. Bronsted is, and it's that proton that's what's the definition of an acid, right? Bronsted is about protons. Okay. So I do see a proton in the first reaction. It's in HBr. Guys, protons are the things you learned the pKa's for. HBr is one of them, right? So if you're attacking a proton, you've got everything going on. You got the Lewis and you got the Bronsted. Okay? So you ready? Always start with Lubnu. Because the start of your arrow makes that a Lubnu. We're going to go with the label. You're either a Lubnu or an Ela. How did I make my decisions? How did I make those decisions? Where you start is the donor, right? Yeah. You're always a Lewis base if you're the beginning of the arrow. But this molecule is at the beginning of this arrow. It's a Lewis base. And it's a nucleophile. Now the question is the arrow attacking a proton or not? Yes, you better add Bronsted base as well. BB. And some of you have seen the videos already and had your little chuckles, but I like saying Hubnu Habibi. Right there. I'm in Dearborn. I love my students. Okay. Okay. Yeah. It's sad, but I'd love to use Elba too, because it's another Arabic word I love. But that mixes acids and bases together, and that's not good. Elba, your heart. Don't use Elba. I'm sorry. But it is a Bronsted acid, which makes it a little like Elba. It's Ilaba. I should do those in black. It's not black. And it's a ba. Ilaba. Now this next one is not. Where's the Lubnu down here? Where's the Lubnu? Yeah, where the arrow starts. Lubnu. And don't add any more letters, please. Lubnu. Is it attacking a proton? No, it's attacking a carbon. Do not add any Bronsted at all. It's not a Bronsted reaction. Okay. Lubnus always react with Elas. Now, where's the Lubnu down here? Hydroxide or the carboxylic acid? Which one? Hydroxide. Is it attacking a proton? It is. It's the whole ball of wax, isn't it? Lubnu Habibi. And the thing that's giving up the proton, Ilaba. Bronsted acid. And this one over here is a Lubnu. Oh, it's black. Lubnu and Ela. You're not attacking a proton. Don't put Bronsted. And labels for resonance. Or reactions with only one reactant. Okay? Don't put labels on something that's like not reacting with another molecule. Those labels are for how are they interacting with each other. If there's not two things interacting, please don't label. We have a question. The combination of 1, 2, and 3 is a mechanism, and we'll be doing a journal entry later today. It's like an intro here. And I think we've done all the parts. How are they graded? Well, I showed some ways you can lose points. The ones I did correctly, I'll just tell you. Let's continue with this grading. Grading. 1 point for each set of arrows. 1 point for each intermediate you draw. Okay? And that's the big points right there. As we do mechanisms, I'll show you where you're getting your points. Right now, these are just little bits, little snippets of mechanisms. I want to show you the big picture. Coming up real soon. Okay? We didn't have to draw any intermediates on this one. They were all there for us. That won't always be the case. We're going to stop and start activity 2.